Today we're going to talk about projectile motion. We learned how kinematic equation used to describe objects' horizontal and vertical motion. On the other hand, if an object moves with these both directions and thrown or fires in the air, the concept of projectile motion takes place. Projectile motion is any object that is thrown horizontally or at an angle and subjected to gravity. In horizontal motion, the acceleration usually is equals to 0, while the horizontal motion, the acceleration is equals to g, or acceleration due to gravity, which means acceleration is equals to 9.81 meter per second squared downwards. So, for example, imagine a ball is thrown horizontally at a certain angle and it falls to the ground, creating a curved path. So, that curved path is called trajectory of the projectile, and its shape is parabola. The horizontal distance between the point where the object is placed before it is thrown and where it falls is called range. In solving a problem, you will need to create two equations, one for horizontal motion and one for vertical motion. And there is similar variable between the two, which is time. Since the object is thrown in the air, we neglect the effect of air resistance.
Imagine you're a basketball player. You threw the ball to your teammate in a certain distance. A parabola is formed. The parabola depends on the speed of the ball and the distance of your teammate. Why is so? In another scenario, imagine you're on a cliff. You kick the soccer ball off the cliff. Then you went to the lower cliff and kicked the soccer ball with the same speed as the former. In which part of the cliff does the ball's final position has greater distance from the foot of the hill? Projectile motion explains it. But what is projectile motion? Projectile motion is any object in motion with initial velocity and whose path is determined by the effects of gravity and air resistance. The path being followed by a projectile is called trajectory. Object travels some distance in a horizontal direction, or it can also be vertical direction, and it can also be a combination of horizontal and vertical direction, but they are independent with each other. There are three factors that affect the projectile. First is the time. It is the entire time while the trajectory is on its trajectory. Second is the range. It is the horizontal distance traveled by the projectile. And third is the maximum height. It is the max vertical displacement traveled by the projectile in its trajectory. For you to further understand the terms of projectile motion and its computation, here is your next reporter.
By using Phet, we will demonstrate what is the relationship of angle and range. In this example, we will use 60 and 30 degrees to see the relationship. By having the same force, an object with different angle will land on the same spot. And if the cannon is placed in a higher place, like a 5-meter platform, shooting the object with 60 and 30 degrees, still having the same force, it will result a different range to one another.
Yung papaliwanag lang natin dito yung relationship ng range tsaka angle sa projectile motion. Sabi dun sa na-search ko, kapag closest daw sa 45 degree, then kapag mas mataas sa 45 degree, mas mataas lang yung yung maximum height niya, pero yung range niya mababa. Tapos yung dito naman, kapag lowest sa sa 45 degree, mas mataas yung range, mas malayo yung range, pero yung maximum height niya mababa. For example, 60 kunwari, 60 degree yung yung piner mo yung cannonball kunwari dito. 60 degree. Siya 45 60 minus 45. Meron kang difference na 15 degree. So, gagawin mo dyan, 45 minus 15, meron kang 30 degree. So, dito, 30 degree. Kapag ipiner mo to, mataas lang yung range niya. Pag same velocity, mataas lang yung maximum height niya. Pero yung range niya mababa. So dito naman, kapag nag-fire ka sa 30 degree, mababa yung height niya, pero dun pa rin, parehas lang sila. Kasi closest sila sa 45 degree, parehas sila ng na 15 lang yung difference sa 45 degree. So, parehas lang yung niya. For example naman, paano naman kapag elevated kunwari. Elevated yung piner mo. Ayan, kunwari ganyan. Imbis na yung height mo, ito lang, yung x-axis mo, ito lang dapat. Meron kang height na dapat sundan pa. Kunwari, ito, table. Ito yung height ng table. Or sabihin na natin, basta elevated yung surface. So, susundin din natin to. Ito, 45 degree. For example, uli, yung 60-30 natin. 60... Ay, wait lang. 60 tsaka 30. Yan, 60-30. So, alam naman natin na, kunwari, ito lang yung yung point A niya, ito. Yung maximum height niya, ayun yung point B. Kunwari, ito, yung sa 60 degree, nagganto siya, nag-travel siya papunta dito sa point C. Ito. So, alam natin, di ba, paras nga lang yung difference ng 30 tsaka 60 kapag sa 45. So, ito, yung point A nito ng 30, magta-travel siya pa ganito. Papunta doon sa point C. Parehas lang ng ng range, di ba? Pero magkaiba ng maximum height. Ito yung maximum height ng 60, ito yung maximum height ng ng 30. So, dito magkakaiba na sila. So, pansin naman natin na ito, patusok na talaga, pababa na talaga. Ito, so magaganyan siya patungo dun sa ground, which is sabihin na natin point D. Tapos ito naman, yung sa 30 degree, alam na natin pag ganito pa lang yun, di ba? Hindi pa siya yung talaga. So, magta-travel siya ng pag ganito. Mas malayo yung niya, yung range niya. Mas malayo talaga yung range niya. Kesa dun sa sa 60 degree. So, masasabi natin na maganda yung conclusion na yun, mas madaling maipaliwanag na kapag mas close sa 45 degree, ay mas mababa sa 45 degree, mas mataas yung range. Pag mas mataas naman sa 45 degree, mas mataas lang yung maximum height. For example naman, 80 naman, 80. 80 yung angle niya dito. Tapos 80 minus 45, 7, 3, 5, 35. 35 minus 45, meron kang 10 degree. Dito lagyan natin 10 degree. Ayan. Elevated surface pa rin ha. Elevated surface. Ito, magta-travel siya. Same velocity pa rin. Magta-travel siya pag ganon. Hanggang dito sa point C. Ito point B ulit. Ito naman, yung point A ng 10 degree. Magta-travel siya. Konti lang. Konti lang yung height niya. Pero, ganun pa rin talaga yung height. Yung ano niya, yung range niya. Dito pa rin siya mag-meet. So, ito, patusok na din talaga. So, dito na lang siya. Mapapansin natin na ito, pag ganun nga, so, magta-travel siya, papunta doon. So, ito, yung 10, mas mataas talaga yung range niya kapag mas mababa sa 45 degree, ah. Tapos ito, mas mataas lang yung height niya kapag mas mataas sa 45 degree. So, ayun lang, ganun lang yung relationship niya ng projectile motion sa elevated surface. Kumbaga, dito sa example natin na to, kapag ganito, nagmi-meet kapag parehas lang ng angle. Nagmi-meet sila dito sa point na to. Pero kapag elevated na, doon natin malalaman na mas mas mababa yung height nito, pero mas mataas yung range, mas mahaba yung range. Ito, mas mataas yung height, pero hindi ganun ka haba yung range niya. So, ayun lang.
Kapag hindi po elevated yung ginamit natin, ang formula po natin is R is equals to B squared sine times 2x over G. So, kumuha po ako ng example. Kunyari po yung velocity po natin is 10 meter per second squared and yung time po natin is 5 seconds. So, sakto na po yung hinahanap natin kasi po, ang hinahanap po sa tanong na to is yung range. So, ang pinaka-formula lang po niya is ganito po. Iaano lang po natin siya, isa-substitute lang po sa formula. Yung b squared equals to 10 meter per second squared times squared. Tapos, bali, dahil po, ano po siya, not elevated, sine. Tapos, yung given po natin is 60 and 30 degree. Ang una po natin gagamitin is 30 degree. Then, times 10 over 9.8 meter per second. So, yung nakuha ko po dito is kapareho lang po nung ginamit natin sa 60 and 30. So, kapag po not elevated, magiging magkapares lang po yung sagot niya sa degree, kahit magkaiba po ng degree, magkatulad pa rin po ng sagot. At kapag naman po sa elevated, dito po nagkakaiba yung sagot nila dahil iba na po yung formula dito is R is equals to B times cos times X times time is equals to G. Dito po sa formula to nagkakaiba na po yung sagot nila kahit po magkaiba yung degree. Hindi tulad po sa not elevated, magkatulad pa rin po yung sagot kahit po magkatulad yung degree. Yun lang po.
This is the summary of the projectile motion. In Jadin's and Mary Grace's report, they talk about the introduction of the projectile motion. It is an object moves along a curved path under the influence of gravity, and it is also formed a parabola. There are two independent parts of projectile motion. First is the horizontal motion, which has an acceleration of 0. Second is vertical motion, with an acceleration of 9.81 meters per second squared, which is based on the gravitational force. We have three factors that affect projectile motion.
First is the time, second is the range, and the last is the maximum height. In Paulo's report, he demonstrated the relationship of projectile motion using the game which will be shown above the screen. In Ave's report, he discussed and showed a graphical presentation of relationship of angle and range. In his report, he stated that if it's above the 45 degrees, the height is increased, the range is decreased. Otherwise, if it's below the 45 degrees, the height is decreased and the range is increased. In Jandel's report, he solved a problem and used this formula, which is R is equal to U squared times sine 2 theta over G. And that's it for the tutorial video. Thank you for watching, and I hope you learned something from us.